So, and in this video we are actually building the arcade cabinet, and we are going to talk about tools. I'm going to give you tips, I'm going to show you how to connect panels. Everything you want to know. It's a great look behind the scenes. We are going to have so much fun. So without further ado, let's start cutting out some panels. So, and before you start any project, it's very important that you have some good drawings. This will help you prevent making mistakes, and every dimension, every angle we need to cut is here. So this is the top panel, and let's start working on that. If you want to cut your large panels exactly 90 degrees over a longer length, you could just use a guide rail and a track saw and then use a square to try to make it 90 degrees. But Festool has this wonderful accessory I wanted to have for a very long time. It's the FSWA accessory, and you can connect it to your guide rail, just like this. And now it's super easy because you have this longer length. And now it's super easy just to cut your panels this way. It's a great accessory. It's not that expensive, and it works really well. For the top part, we got all the panels ready, everything is cut. The CNC work was done already, so all the strange shapes I did not cut here. This was done by the CNC company. Now it's really important to prepare everything. We need to cut T-molding grooves on all the panels that need that, and we need to cut the mitres, and then we can start assembling the top part. So let me show you this contraption here. This is an ordinary router. This is a Festool one, but you can use any cheap, this is a super expensive one, but you can use a cheap router as well. It doesn't really matter for this purpose. So in here is this special bit that is erased to the correct depth. I will put a link down in the description where you can buy these. And basically what is going to happen, it is cutting a slot. Let me show you. So here you can see it's cutting a slot exactly 1.6 millimeters in the middle of your wood, and it's super easy to do. The only thing you need to take care of is that it's exactly in the center, and in this case it is exactly in the center. It's perfect, and the only thing you should take care of is that you really hold the router flat, that it doesn't move, doesn't wobble. You just hold it with two hands, and then you just follow your workpiece carefully. Now we need to cut, let me show you, this mitre here, and this needs to be perfectly cut. So I want to talk a little bit about tools. You see me use all these super expensive tools, all this Festool gear, and let me tell you, you don't need it to build arcade cabinets. You can do almost everything I do with very cheap tools. Just go to the hardware store, buy the cheapest router you can get, it will work. But I would suggest buying two kind of more expensive tools if you're into cabinet building or arcade building, and these are the two I think must-buy tools in my workshop. So the first one, and that will be the most expensive one, this is the track saw. You just saw me use it, and this thing is, I can't imagine building arcade cabinets without one. In a minute we are going to cut the mitre cuts, and this is so easy and so perfectly accurate with these track saws. So buy a track saw, buy a Festool one, trust me, I tried many brands. They are expensive, I know, but they are worth every euro. They come with a guide rail, and make sure you get the guide rail with the small slots here. So the slots are important because you can buy, and I showed this to you in the tooltip already, you can buy these sticky strips and you can just put them inside and it makes your life a lot easier. You don't need as many clamps and well, I will show you in a minute how this works. Second tool I think you should really need is a small tiny drill. And this is ultra light, it's a very high quality one. It's a pistol grip, it fits in your hand perfectly. It is the tool I use most, and if you buy one, and that's the fun part, it comes with all kinds of accessories, like a angle bit driver, and you will need this all the time. And they have this system which is called SpinTrak. You just click everything in, and then you can, everything with this green does something with Festool, so you can insert drill bits or drills, whatever you like. It's a pleasure to work with. It comes with tiny batteries. And this is the cheapest one, the smallest one they sell, and it's absolutely worth every euro. And I think they even have a new one. I will put a link down in the description. I'm not sure what the name is of the new one. This is called the CXS, and the new one I think is just as light and maybe even stronger, but this is an old one and I still use it every day. You can clip it on your trousers just like this, and just a pleasure to work with. So if you want to invest some money, you want to buy some tools, electronic tools, you buy a track saw and you buy a drill, the smallest one you can get. Oh, and about spending money on drills, don't get tempted by buying the most expensive CPC 18-4. This one does have its purpose here in the workshop. It's a beast, but it also feels like a beast. It's really heavy, and this is the one I use with big drill bits, or if I want to cut big holes in cabinets, or I want to drill something in the wall. Very durable, very heavy, but this is not the one you're going to use most. So if you're just starting out, spend less, buy this small thing, go for the pistol grip. It's easy, you can be more accurate, and these are the two electronic tools I would buy. So let's see, and Fusion tells me that the mitre needs to be 52.53 degrees, but the way I measured it in Fusion, this would be if the saw would be lying flat on the table, so 53 degrees would be like this, cut like this. But our saw is 90 degrees, so as you can see, the track saw can only do 45 degrees maximum, and we need 53, so we take 90 degrees, because our saw is 90 degrees, and then we subtract 52.53 degrees, and then what is left is 37.47, so 37.47, and this is the mitre we need to insert here on the track saw. We take our guide rail and we put it on our workpiece, and beautifully aligned. Just feel, make sure the strip, and the strip is where the blade will hit the workpiece, the strip is aligned against the wood. You get these small strips and you place them like this in an angle on your guide rail. And this way you don't need any clamps, just like this, and you do. And now it's absolutely stuck. Look at our beautiful, beautiful mitre. So now that everything is cut, we are going to mark all the panels on one of the sides. And here's the next tooltip. And this is cheap, but quite possibly one of the best tools and most used tools in the workshop. And this is called the Paolini Pocket Ruler, and it's made by woodpeckers. And basically what it does, so you can move this piece here, and there's a small cutout, as you can see here, for a pencil. So let's say that we want 80 millimeters, so 20, 19, 18. Let's put it here. So now it's 80 millimeters. Now I can easily mark, super easy, 80 millimeters from the sides, just like this. So for marking out panels, doing quick measurements, and it's always the exact same distance. So everything is marked out, as you can see here. And now we should test if the mitres are cut correctly. Let's do that now. And to do this, I'm using these woodpecker steel clamping squares. Let's put a piece of tape here. You can see that the mitre is absolutely perfect. It's really, really, really accurate. Perfect. If you are interested in this big device I'm using all the time, it's called the Festool domino. It's very famous. What it does, there is a router bit. I'm not sure if you can see. Is it in focus? So there's a router bit which comes out and makes this movement. So it's turning and it makes this movement, which creates these slots. And in these slots you can place these wooden dowels, which are called dominoes. And these are very smartly engineered. You can easily, just like an IKEA cabinet, assemble your panel just like this. You can easily do this without, just cut some brackets, staple them together, use clamps, use glue. You can do everything I do without a domino. Is this one going in? There we are. This is the first test fit, and it is a success. So let's measure everything. Let's make sure that there are no errors, because at this stage I can still fix everything. So the top part is ready, everything is glued, everything is tight, it looks beautiful, and look at look at the size. It's like, wow! It's this big. I can't imagine how it would be like playing with all these people on this 50-inch cabinet. So now I'm going to build the bottom part and I'm going to build the cabinet part for the consoles. I'm not going to film everything as this would take an endless amount of time, and this cabinet would be ready in 2030. So I see you later when I'm done with the cabinet, and then we're going to install all the electronics and do the artwork and stuff. So it's gonna be awesome.
Alleen de meeste van die mensen stellen.
This is the first major problem, and every build has problems, but this is the first major one. So as you can see here, I made this beautiful cabinet for the consoles, and this needs to fit in the bottom part of the arcade cabinet. The problem is that it doesn't fit. So, which is strange, but we need, let's say, the cabinet to be smaller than 93 centimeters or so. Yeah, 92 point something, 93 centimeters. And when I measure my cabinet, let me show you, this is 94. And I'm not sure what kind of mistake I made, because in AutoCAD I did the correct dimensions and I took care everything was a tight fit. Anyway, it happens. So I need to disassemble the cabinet and change the sides, or make the sides, or make it a little less wide before we can continue. So let's fix this problem first, which will take several hours, and then we can continue.
Many unbearable hours later.
Now there's another puzzle to solve, and this is the Thrustmaster Hotas magnetic base. And there are two problems with it. So it's extremely heavy, and this thing needs to go to this hole. But as you can see, if I would use the footplate, it would cover up everything, the screen, the cup holder, some of the buttons. It's far too big and it's also too heavy. I took it apart, let me show you. And this thing is much lighter. It's really light. This is the inside if you're interested. So I came up with this idea, which will fit exactly here, and it will not touch any of the components. And I drilled some holes and a small cutout for the cable. Now this fits absolutely perfect. Let me look. Wow. It looks like it's really made for it. Well, actually it is. So, nice, nice, nice. And this will go here. Let me test fit it. Beautiful. Perfect. Really nice. And only the metal ring is protruding. Yeah, beautiful. Beautiful. Okay, here's a quick update. We have a terrible problem, and that's the following. I'm working, preparing the control panel, and the plexiglass is not cut correctly. So as you can see here, the holes are beautiful, but the laser engraving is just a few millimeters off. It's it would be okayish, but it's just it really doesn't look very neat, and the engraving is just a few millimeters off. There is also a piece of laser engraving missing, so one of the characters does not have laser engraving at all. This would be okay if it was your home arcade or so, but for my clients we want the absolute best quality. So what I'm going to do, there's only one company that can manufacture these 130 centimeter plexiglass plates. So I'm going to drive, and I don't have time, but I'm going to do it. I'm going to drive 2 hours to pick up a brand new plexiglass control panel. And this is terrible. And the problem is that this mistake cost me about 400 euro. So this is terrible. But we keep our heads up and let's drive to Hoogeveen. perfect, the new one. Great. Okay, it's now about 11 p.m. It was a hell of a trip, but it pays off, it really pays off. I got the laser engraving just absolutely perfect. As you can see here, everything is super aligned. I made it a little bit simpler, a little bit more clear. All the ugly lines are gone and everything is absolutely beautifully in place. So here is the control panel. And now I can't go to sleep yet because I need to make all the custom buttons and insert them here. So these are all the power supplies, and we can just connect them to the big power strip, but that means that this cabinet will have power all the time and the LEDs are on all the time and the screen will give you a no signal error, which is not something we want. So let me show you how to use relays to power on the PSUs or power on everything when the computer is started up. So this is a relay board. And I will put a link down in the description. They are super cheap. And let me show you how they work. You will need to give them power. In this case, it can handle 5 volt or it can handle 12 volt or even 24 volt. And this goes in DC plus, DC minus. So you give this board power, a light will blink. And when this board has power, it waits for signals on in 1, in 2, in 3, in 4. And when it receives a signal from the PC, the relays inside here, these are the blue blocks here. These are all, these can handle 10 amps of current, which is more than enough for our purposes. So they will make a connection. So basically it's an electronic switch. So what we are going to do is we're going to power this off the PC. So when the PC is on, this board will power on. We'll connect it to all the power supply units, which are 4 in total. So when we switch the PC on, if everything works, all the PSUs, the power supply units will start working and the machine will come to life. This is the beautiful power button for the PC or to turn the arcade cabinet on. But if we power it with a regular 3 volt, let me show you. The light is almost invisible. Let me get it in the shade. It is there, but it's almost invisible. And 3 volt is what the computer will give this LED. But ideally, we would like to have 12 volt. As you can see here, if I put it to 12 volt, the light is very bright. These are regular step-up converters. Oh, they come in a set. You can snap them off. And this is how they look. You can put the voltage in, which can be 3 volts or any voltage you got. There's this small screw, and by twisting the screw you can increase the voltage that comes out by voltage out here. And what we want is, well, maybe even 24 volts or 12 volts, whatever. And we're done. I can fix this with a little bit of glue, or no, maybe a piece of tape. This will be even better. And then the button will work. Let's test it in a minute. We are a few weeks in now, and I'm sorry for my clothing. It's kind of casual, but it's about 30 degrees outside, and we are going to do the wiring now, which is very relaxing for me. So it's always nice to have some really comfortable clothes on when you're doing this. So I already did some preparation. So I installed all the buttons. I installed the screens. I did not wire anything up. We are going to do that together. I installed the screen, the hypermarquee screen, the speakers, the sensors, the Gun 4IR sensors. These are the Noctua fans. Everything is labeled. Everything is tight already, but it's even tighter when we are done with this. This thing here is the system for adjusting the height of the arcade cabinet. This is the relay board. So that everything will turn on when the PC is powered on, the subwoofer. So now all that is left is wiring up the control panel, installing the Ipacs, installing the trackball, the Stream Deck. I need to figure out how to power up the RGB cup holders, and we are going to do everything together, and I'm going to give you some nice tips and tricks. And to wire everything, we are going to use 2 Ipac boards. 2 Ipac boards are enough, but as this build also has a real PlayStation 5 and an Xbox and a Nintendo Switch, I'm also going to install some Brook fighting boards. So this will be a more complex build, as we have Brook boards and we have Ipac boards, but you can use this video for either of them. So basically this is an Ipac Ultimate board. These boards are made by Ultimarc, and these are absolutely amazing quality. So what they do, they convert button presses to keyboard strokes. And as you can see, Ipacs are labeled in a really easy way. So you can see player 1 left, player 1 down, player 1 switch 2, switch 4, switch 6. So everything is labeled. And these rows of columns are for the RGB lighting. And when you order these Goldleaf buttons, these are Goldleaf convex buttons. So I talked about this in the previous video. These do not have the dent in them, but a small round cover. So what you would get is a button and this ring, and you will need to cut a hole of 28 millimeters. I do 28.2, so you have some slack, or 28.5 millimeters. You just insert the button. The wire comes pre-attached, and then you just screw it on your control panel by tightening the black nut. And then you can buy this industrial Lorenzo wrench, and you will need to drill a hole in it, because if you buy it, you cannot use them with the Goldleaf buttons because the wire is already attached. So you drill a small hole in it, and then you can just easily route the cable through, and then you can tighten every button. But I already did it for the entire control panel here. So at the inside of the button you can see let me remove the wires a little bit. You can see 2 terminals, and the orientation does not matter. One terminal goes to ground, so we're going to connect all the buttons to ground, and the other terminal goes to the player input. So it goes to one of the corresponding buttons right here. And these colored wires are for the RGB. And this is also included on the Ultimate I/O board. And you just take the wire and you can check what the orientation is, plus RGB. So the plus is the yellow one, this is the 5V. So you just connect it just like this, and then your button will have LED lights. So this barrel jack adapter is for the LED power, and you will need 5V to it, and you will need to get it from your PC, maybe a SATA cable, or you can use a power supply. Anyway, you need 5V for the LEDs, and of course you need the RGB and the USB connection. So when the board is connected to the PC and is connected to the LED power, the 5V power, the buttons will light up. So when you're working on a new control panel, the first thing is figuring out where the Ipac and the Brook or any of the boards will be placed. So a indicator for this is the length of the RGB cables. So these RGB cables can go in this area right here. They can cover any area just up to here. Let's take these ones. These can go here and all the way, well, about up to here. So I always like to start by inserting all the RGB buttons to the Ipacs before mounting the Ipac itself, and then later I will do all the grounds and the button inputs. You can just randomly take a wire and just install it anywhere you like, but then the startup sequence will be all messed up. So I would like to do it in symmetry. So we have 2 Ipac boards, and I will wire the left side of the panel and the right side of the panel identically. And as you can see, this is just really easy to do, and I will mirror that with the other Ipac. So let's get the other Ipac. Most of the LEDs are connected, and then we have these LEDs for these mouse buttons, which are 24mm buttons, and these do not come complete with the RGB wiring. These are not RGB buttons, by the way. This is single color, so I need to make a wire that goes from the plus and minus to the plus and one of the pins on the Ipac. I think you can even buy them ready to go, but I think I will make one quickly. So now we have a 4-pin DuPont connector on one side and 2 crimp connectors on the other side. So let's install them. This will go here. Now let's install the RGB handle, how do you say, accessory, and this will make your joystick ball tops light up. Super simple to do. So this is the joystick. Just take a small screwdriver and get the clip out. Let's get the black cap out. Let's get the spring out. Now you will get the new shaft, and here you can see that it contains the RGB top here. So it's connected in this position. Now you insert it through the metal washer, through the plastic washer. Then we install the spring. Then we install the black cap, the small clip, the black clip. And now with a pair of pliers, lock it in place. Oh yeah, this is the RGB part. I hope it's long enough. It is, yeah, absolutely. And I usually make this a little bit shorter, as my panels are always 10 centimeters in depth or in height. And I will cut open this shrink tube. And now all I'm going to do is make it really tight, just like this, around it. Just like this, so it's a little bit smaller now. It has a smaller footprint. And now I need to do it for all other joysticks as well. So the Ipac boards are mounted. I did not do wiring management yet. These are just some temporary clamps to keep everything organized, and it looks already very clean. And now I'm going to install the trackball. I'm going to install the servo stick board, and then we are going to work on the RGB cup holders. Let's do that. So this small board here is the RGB board for the trackball. You can order it separately on the Ultimarc website, and you can just easily connect it like this. And a common thing, or a common question is, and we had a YouTube comment on this lately as well, is that you need to wire the ground cable, the black one, to your Ipac Ultimate board or to your PAC-LED controller. If you forget to do this, it does not work. So normally for all the other buttons it's just yellow, green, red and blue, but for this board you also need the black wire connected to ground. So I mounted the RGB cup holders. This was a lot more work than expected. It took me an entire afternoon. Well, almost. So let me show you how they are mounted and connected. So you will need a 12-volt power supply. So this is the power supply coming in. And the positive wire is connected directly to the positive wire of the cup holder. Okay, so positive 12 volt goes to, in this case it's a black wire, strange but true, and this goes to cup holder 1. And I daisy chained every cup holder together, so everything that's connected to this cup holder goes to all the other cup holders. The ground of that power line is connected to the high current, I'm not sure if you can see it, the high current output black terminal right here, and it's connected to the 5-volt connector. I know it's strange because it's ground, but you need to connect it to the 5-volt connector right here. Then you have RGB, which is obviously connected to the RGBs here. And again, this is all daisy chained. So 12-volt power line, the positive wire is connected only to the cup holder. Ground is connected to plus 5 volt on the high current terminal, and an RGB is connected directly to the cup holder, to the black terminal. And in Ipac software we should enable high current output. So this way the ultimate I/O board can drive these 12 volt high amperage cup holders. So now I will add the Brook fighting boards everywhere, and I need to power up the complete control panel. So I will need to give it, let's say 12 volt power for the RGB cup holders. I need 5 volt for the screens, 5 screens, 5 volt. Let me see, I need 5 volt for the Ipacs right here. So I will start working on that and I will see you in a minute. The USB UP5, not UPS, UP5 Brook upgrade kit. So you can use your Brook controller with your PlayStation 5. You will get this small PCB and you will get some wires. Let me get this out of the way. So let's connect the big cable here, and this cable goes exactly on the small side here, just in here, and then there is a small power cable. You connect it here, and this goes to 5 volt and ground on the blue terminals. So let's install it here. Volt is over here, and now all we need to do is mount a small PCB somewhere. Perfect. And now let's install the spinner head. And I have 3 colors. So let's see which color we should pick. The blue one is really nice. The chrome one is great also. And black. I go for blue. Decided. Put them in. Just like this. Tighten them. The other side as well. Nice. Looks absolutely beautiful. So here, difficult to see, but here is the spinner. This is the spinner connector. It is brown, green, white and yellow. And we can find it here, which says spinner on the Ipac board. And we connect it. Everything is labeled. Make sure the left pins are untouched. So brown is not the most left pin, it's the second pin from left. So I worked an entire day on this control panel and it looks like the cockpit of a Boeing 737. But it wasn't a nightmare wiring it at all. It was actually quite a lot of fun. And as you can see, it looks pretty good already, but we're only halfway, as I did not connect the button inputs yet and not connect all the grounds yet for the button inputs. But at this stage it would be a great idea to test our work. If there's something broken, we can still fix it easily at this point, and later when we have even more cables, it's more difficult to get at tight spots. So in a second I'm going to press the power on off switch. And the PC will start up. It will supply 5 volt power to the relay board. We should hear a loud click. 4 relays will trigger. So this will give power 12 volt, 5 volt, 12 volt to all the other components. And if we wired everything correctly, Ultimarc Ipac boards should light up. So all the buttons should light up. The cup holders, if they are wired correctly, should light up. And I'm really curious if the 4-channel switcher, the HDMI switcher, is putting some images on all the small displays. So it's exciting, and if something is not working, we will fix it together. We will troubleshoot it together. Let's press the power on button. The PC is powering on, but the relays are not triggering. As you can see, the relays are not triggering, so there is something wrong with the relays. Okay, let's troubleshoot that first. So here we are at the back of the machine, and you can see the PC is working quite well. I can also see the relay board is getting power from the PC as the LED is burning, but I did not hear the loud click. This means that the relays are not activated. I found the problem. I disconnected the relay board. As you can see, the relay board is getting 5-volt power, but I forgot to use the signal to give it signal inputs. So let me show you how that works. So the relay board is rewired. Everything is set up, and now let's see if we got something happening here. I hear the loud click. The lights are turning on. I can see the amplifier. I hear the fan spinning very loudly. I can see the LEDs on the Ipac board. I see some LEDs here happening. Let's take a look at the other side of the control panel. Oh, okay. Oh, that looks really good. That looks really, really good. And what is not working yet is the ring light right here. The polarity is wrong, and let's reverse this. Now it's working. I can see 12 volt. Let's go all the way to, oh, this max is 20 volts. Let's go to 19. And now we can see the beautiful, bright 19 volt push button. Get the control panel in place. Let's install the ball tops. So we are well on our way, and this video is getting far too long already. But there are two things I want to do together with you, if you like. So the first thing we should do is we should wire up all the buttons. So every button needs to connect to ground, and it needs to connect to the Ipac controllers. Or I can choose to only use the Brook Universal Fighting Boards, because they work with PlayStation, they work with Xbox, they work with the Switch, and they work with the PC. So I'm not sure. I asked Chris Shaw from Hyper Arcade System for some advice. So depending on what he says, I might wire everything up, so and the Ipacs and the Brook Fighting Boards, or I only wire up the Brook Fighting Boards. And in case I need to wire up both of them, I have a really cool idea for that as well. And the second thing we need to do is install the switch, as we have one big monitor here, and this is the same monitor that's going to be used for the PlayStation, the Switch and the Xbox. And to do that we need to switch HDMI, and we need to switch USB, of course. So here's the switch. You can see all the HDMI ports and the USB ports. So we have 4 PCs. In our case it will be the Xbox, PlayStation, Switch and the PC. And in the back we have the 4 inputs. And these 4 inputs will be the Brook Fighting board. So 1, 2, 3, 4, and already wired, already connected to USB cables. So here you can see that you can switch it by pressing these buttons, which is easy enough. So let's see how this thing works. I will borrow the 5 volt for the splitter. I'll give this 5 volt. Insert the, oh here you can see the small lights is now on 3, 1, 2, 3, okay. And this is the switch I'm connecting. And now let's see how this works. Okay, so this works really well, of course. So I can easily mount the switch somewhere underneath the control panel, Most people would do that, but no. We are going to wire them to individual buttons specially designed in this control panel. And these will have logos of the different consoles in the computer at the back in the artwork. So it's going to be absolutely beautiful. What we should do is take this thing apart and see how we can, well, wire it up to these buttons. Let's see how this is wired. I hope and I suspect that this is going to be pretty easy. Let me get this straight. I'm not sure if you can see the light. So if we shorten the blue one for the white one, it's player 2. As you can see, player 2. And blue and green is player 3. And blue and red is player 1. So this is a standard 2mm, 2.1mm daisy chain wire. This is just for ground. So we will ground all the 90mm buttons, and then we wire this to the blue button, which is ground as well. Let me get some crimping tube. There it goes. There we go. And let's make it a little bit bigger. Oh, so sorry. And there we are. Luckily it's not shielded. Like this. And we will twist the two together. After you applied the crimping tube, obviously, like this. And now we will solder it together. Just like this. And now, let's get the crimping tube over it. And there we go. So, ground is done. So you don't need to watch all of this. I will speed it up and I will get back to you when we are ready. And there we are. There we have our custom cable. Professionally made, and it looks really, really nice. Green. Now let's see if they are working. And they are working beautifully. So 1, 3, 2, 4. Perfect. Amazing. Really beautiful. So I will mount this in the back next to the PlayStation, Switch and Xbox. I hope the USB cables are long enough. I think so. And then finish the wiring and then we can test. So these are complete Brook harnesses. And actually these are great. Let me unwrap it for you. So they come pre-wired and you can insert them right into these headers. So and these headers here are exactly the same as the blue screw terminals right here. So you can just connect them. Let me check the orientation. They already have the correct length as well. So I hope, yeah, I have room enough. So just let's take our multimeter, put it in continuity mode so it will make a beep. And then let's see. The smallest one is the blue one. And everything is beautifully labeled here. So let's see if the blue one is first player punch. Correct. And as for ground, which is a lot easier than usual, there's a small daisy chain with 8 connectors here. So we can just easily daisy chain these, and these are more than long enough. So let's start by doing that. That was quick. So the daisy chain, the ground connectors are all connected to ground. Now this is button 1, player 1. So this is this one here. And now all we need to do is wiring the joysticks. If you're using Sanwa or Samitsu joysticks, probably you can just hook them up very easily with this connector. But as we are using the Ultimarc joysticks, you can easily do this too, but you need to make some custom connectors. So let's do it like this. Let's cut every one a little bit, just strip them out, just a few millimeters. Just like this. Grab a connector. And make sure it's all the way matching the red dot. Zap. Zap. Make sure you pull it, and this will never come apart again. Now let's do the yellow one. So this was down. This left. And zap. The green. I know, is that right? Okay, and we are done with player 1. So here you can see exactly how I wired it. So the input is at the terminal right here. Normally open, I think. Yeah, normally open. So all the grounds are connected to the common connector. Let me do player 3 and player 4 and player 2. Do the cable management, and then I will see you in a minute. So now let's test the spinner. And the spinner is working. I hope you can see it. There's the mouse cursor, the spinner is working. And now let's test the trackball. And the trackball is working, but if I move the trackball up and down, the spinner or the mouse cursor goes left to right. And this is a common problem. And this means that I wired it incorrectly, and it's super easy to solve. So let me quickly show you. So here's the trackball, and this is the original wire. And I made some extension wires that run all the way here, to there, which says trackball. And the trackball is connected right here, where you can see trackball. And if your X and Y coordinates are in the wrong direction, just switch them out. So the top one goes in the bottom, just like this. And the bottom one goes, let me see if I can do it, in the top one. So I switch the connectors, and if everything is all right, the trackball will work again. And we are almost done. I finished most of the cable management. I still need to do the 2 back doors. I will take care of this now. I had a big problem with the relay board. Finally, I ended up by changing the complete relay board for some really heavy duty ones. Let me get them in focus for you. And this one has much more amperage. The other one was just too small, and I used that one for switching 10 volt or so. But this one is a lot more powerful, so I placed this big board inside the cabinet, and that solved that problem. The switches work beautifully. I installed the stream deck. Everything works absolutely great. I finished the drawers, and I'm really happy with those. So these look absolutely amazing. You can see all the controllers, 2 PlayStation, 2 Nintendo Switch and 2 Xbox controllers, and the drawers run so beautiful. And of course everything matches with the artwork. So, and let me quickly show you around the complete wiring, because I did not videotape everything, so I'm going to quickly tell you how everything is wired. So this is the control panel from the inside, and from right to left all the buttons, they are connected to Brook fighting boards. We have 4 Brook fighting boards in total, and these Brook fighting boards 1, 2, 3 and 4 are all connected to the switch in the back of the machine, and this is the HDMI switch, and this will switch the screens to the PlayStation, to the Xbox, to the PC, and to the Switch, the Nintendo Switch. I also use two Ipac boards. One is here and one is right here, and this is the Ultimarc Ultimate I/O board. And these Ipac boards are driving all the LEDs and only a few buttons. So the Ipac boards are connected to the trackball, they are connected to the two mouse buttons, and they are connected to the administration buttons, which means pause, exit, menu and an enter key. So the only thing the Ipac does in this build is drive the LEDs and just a few 4, 5, 6 buttons, a trackball, and also a spinner is connected. The cup holders are 12 volt and they are driven by just one Ipac, which is the right Ipac, and these are connected to the high power output driver from the Ipac. The black box here contains the Hotas Warthog Flightstick, which is connected through USB. Player 1 and player 2 are servo sticks, and they are connected to the servo stick board, just like this. And the servo stick board is connected with a mini USB cable all the way down here, and it goes directly to the USB hub. There are 5 screens in the control panel, 4 small ones, one here, one here, one here and one here. And these screens need 5 volt. They're all connected to the 5 volt line, which is connected directly to the PSU in the main cabinet. And all 4 screens are connected to this HDMI splitter right here. And there is a HDMI cable coming in and 4 signals are coming out. So all the small screens, they will share one signal, which is important to know. So you import one signal and all 4 screens display the same image. And this is the 5-inch screen and it's connected directly to the PC, so it can have other artwork. So this is how the screens are set up. The small buttons here, the 19mm push buttons, are all connected directly to the switch, to the HDMI switch and the USB switch inside of the cabinet. So every time we press one of the switches, it will switch to the PlayStation, to the Xbox, to the Nintendo Switch or to the PC. So the screen will change and the controllers will change. So the Ipac automatically switches to use the consoles, and this really works great. These are 2 USB plugs connected directly to the USB hub. These female barrel jack adapters, they will supply 5 volt, and these are for the gun for IR guns. So you can see that here, this is just a splitter for it. So this is just 12 volt. This is the amplifier, and the amplifier is also receiving 12 volt, and the amplifier is connected. Everything is labeled to the subwoofer and to the 2 Visaton speakers right up here. The audio is connected with 2 RCE cables that are running directly to the main monitor. And let me show you the back of the monitor. Normally I will use the headphone output, but this TV does not have an headphone output. So in this case I'm using the optical output here, and this optical cable runs directly to the digital to analog audio converter. So here you can see the red RCE cable going through the cabinet into the control panel, connected directly to the amplifier. All the USB cables are connected right here to this USB port. Let me see if I can show you. This is a huge USB port. 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 10 ports, which is quite amazing. Every port can be turned on and off with the press of a button. As you can see here, there's a small indicator light right here. So these are all the USB ports that are connected to the PC. And the Brook fighting boards are connected here. Player 1, player 2, player 3 and player 4. And this is connected directly to the PC. It's connected to the PlayStation, to the Nintendo Switch and to the Xbox in the back here. So as for power, there's a power cable going into the cabinet. There's an on-off switch right here. It's traveling directly to the power strip, which is a 10-port power strip right there. So from the power strip, power is coming to this device here, which is the relay board, and the relay board is connected to the PC. So basically when the PC is turned on, all the relays will turn on, and therefore turning on all the power supply units, the PSU. So all these power supplies will be triggered when the PC is turned on. So this is how the cabinet is wired. So I still need to do the two back panels, do a little bit of cable management and some of the software. So this is it for now, and I will see you in part 3, which will be a short video, I promise you, with the end result. And I'm so excited, I can't wait. Please, if you have any questions, put them down in the comments or feel free to write me an email. Thank you so much for watching. Please like and subscribe to the channel. This will help the channel grow, and forward this video or this channel to your friends if they are into arcades. Making these videos it takes so much energy and so much work, and it really helps me out a lot if you would share it with your friends. Thank you for watching, and I will see you in part 3 with the end result. See you then.